In the last lecture, we reframed growth and division as dangerous commitments that cells must justify. That framing leads directly to the next question. What happens when damage accumulates, growth is risky, and repair may not be enough? At some point, survival itself becomes a liability. Before talking about repair or elimination, we need to be clear about something fundamental. Damage is not an exception in cellular life. It is the baseline condition. Cells operate in a chemically aggressive environment. Reactive byproducts form. Replication introduces error. Mechanical and metabolic stress accumulate. No amount of regulation eliminates damage entirely. The real problem is not avoiding damage, it's deciding what to do about it. Repair is the default response to damage. Repair preserves existing structure. It maintains continuity. It avoids the cost of replacement. Cells invest heavily in repair systems because most of the time repair works, but repair is not free, and it is not guaranteed. Repair solves problems until it doesn't. Repair consumes energy and attention. While repair is active, growth is delayed, specialized function is reduced, signaling remains engaged. If repair succeeds quickly, the system recovers. If repair drags on, the cost of repair itself becomes a problem. At some point, continuing to repair increases risk rather than reducing it. Cells are cautious when assessing damage. Missing serious damage risks propagating failure. Overestimating damage costs time and function, but preserves safety. Because these risks are asymmetric, damage responses are biased towards restraint. Cells pause early, long before damage becomes catastrophic. Repair is the default. Elimination raises an uncomfortable question. Why would a cell ever choose not to survive? In multicellular systems, survival is not always the highest priority. A severely damaged cell cannot be trusted to function correctly, disrupts coordination, threatens surrounding tissue. At this point, survival of the individual cell becomes a risk to the system. Elimination is not failure. It is containment. Elimination is dangerous too. It removes function. It disrupts structure. It can provoke further responses. That's why elimination is never triggered lightly. Cells require sustained converging signals before committing. Elimination reflects persistent, unacceptable risk, not transient stress. Between repair and elimination lies a state that is often overlooked. The most dangerous condition is not acute failure. It is chronic, unresolved damage. Repair remains active but ineffective. Elimination is postponed. Instability accumulates quietly. Many long-term cellular problems arise not from choosing wrong, but from failing to decide. Timing determines the cost of damage decisions. Early elimination contains risk. Late elimination requires escalation. The same decision made at different times produces very different outcomes. Correct decisions made too late still fail. If we step back, damage responses take on a different meaning. Repair and elimination are not opposites. They are parts of the same strategy. Repair preserves continuity when risk is acceptable. Elimination protects integrity when risk is not. Delay buys information, but it also increases cost. Cells are not trying to survive at all costs. They are trying to protect the system they are part of. This is the core idea. Damage responses are not moral choices. They are risk calculations. Once you see this, elimination stops looking like failure and starts looking like protection. If cells sometimes sacrifice themselves to protect the system, the next question becomes unavoidable. What happens when cells specialize and give up autonomy entirely? That's where we go next.